This is a sonification for the Planetary Nebula, the Cat's Eye Nebula, also called NGC 6543 or Caldwell 6. The image is made up of 4 different surveys assigned to different colors including X-ray and visible, with each survey assigned different sound frequency in sonification. The data assigned magenta color is X-ray survey taken by NASA Chandra X-ray telescope assigned A8 musical note pitch. Those in blue, green and red colors are 500.7 nanometer, 658.4 nanometer and 656.3 nanometer visible range data from Hubble Space Telescope assigned C7, E5 and F3 musical note pitches respectively. The data was obtained from NASA Chandra OpenFITS archive. The Cat's Eye Nebula lies in the northern constellation of Draco, and its high-resolution images by the Hubble Space Telescope reveal knots, jets, bubbles, and complex arcs being illuminated by the central hot planetary nebula nucleus. The nebula is believed to be generated by binary star system due to its polar jet-like extensions. Observations at X-ray wavelengths by the Chandra X-ray Observatory revealed the presence of extremely hot gas within the nebula with the temperature of 1.7 million kelvins. It is thought that the very hot gas results from the violent interaction of a fast stellar wind with the material previously ejected. This interaction has hollowed out the inner bubble of the nebula. The red, green and blue channels from the Hubble Space Telescope show singly ionized hydrogen, singly ionized nitrogen and doubly ionized oxygen respectively from the nebula. The true colors at these wavelengths are red, red and green respectively, but the false colors are used to distinctly show the emissions. The Hubble image reveals two caps of less ionized material at the edge of the nebula. Deep spectroscopic analysis of the nebula may indicate that it contains a small amount of material which is highly enriched in heavy elements. Deep images reveal an extended halo around the nebula that was once ejected by the central progenitor star during its red giant phase. Hubble images show a series of concentric rings outside the bright inner portion of the nebula thought to have been ejected before the formation of the planetary nebula, while the star was on the asymptotic giant branch of the HR diagram. These rings are very evenly spaced, suggesting that the mechanism responsible for their formation ejected them at very regular intervals and at very similar speeds. Now, let's move to the sonification of the nebula.